Welcome to Maths on YouTube. In this video tutorial, we're going to learn about some basic mathematics topics. This video is for those of you who really want to boost their math skills. So, we're going to learn about how to add and subtract, especially with negative numbers, how to multiply and divide, and how to convert fractions into decimals. We are also going to talk about how to add, subtract, multiply, and divide fractions, and how to convert them back into mixed numbers. At the end of this video, we are also going to talk about what arithmetic is. So let's get started. Let's start off with a basic addition problem. So if you want to add 4 plus 6, what do you get? Well, now for those of you who know, you know that it's 10. But what if you didn't know the answer to this? How would you figure it out? What you can do is you can imagine a number line and starting from 4, you wish to move 6 units. But do you move to the left side or the right side? Well, if you want to add something, you move to the right side of the number line. And if you want to subtract something, you move to the left side. In this case, we want to add 6. So we move 6 units to the right. 1, 2, 3, 4, 5, 6. You end up at 10. So that's why 4 plus 6 is 10. Let's look at some other problems. Let's look at 7 take away 6 now. So 7 take away 6 is 1. So let's prove that on the number line. So you start from 7 and you move 6 spaces to the left hand side because you're subtracting. So you start from 7 and you move 1, 2, 3, 4, 5, 6 spaces to end up at 1. What about 5 take away 8? So this time you start at 5 and you move 8 spaces to the left. So you go 5, so 1, 2, 3, 4, 5, 6, 7 and 8. You end up at negative 3. What about negative 4 plus 7? So this time you start at negative 4 and you move 7 spaces to the right hand side because you're adding them. So you start at negative 4 and 7 spaces to the right hand side is 1, 2, 3, 4, 5, 6, 7. Positive 3. What about negative 10 plus 5? So you start at negative 10 and you move 5 spaces to the right hand side. So you end up at 1, 2, 3, 4, 5. You end up at negative 5. Now what if we have a problem like negative 5 take away negative 4? Whenever you have two negative symbols next to each other without a number in between, you can convert that into a positive. So this is the same as negative 5 plus 4. And we know how to do that. Negative 5 and 4 units to the right. 1, 2, 3, 4 is negative 1. Now I like to think of it as positive is our friend and negative is our enemy. So our friend's friend is our friend. Our friend's enemy is our enemy. Our enemy's friend is our enemy, and our enemy's enemy is our friend. So if you have a problem like 5 take away negative 4, our enemy's enemy is our friend, so this turns into a positive. 5 plus 4 is 9. If you have a problem like 4 take away positive 3, enemy's friend is our enemy, so this turns into a negative. 4 take away 3 is 1. If you have a problem like 6 plus negative 4, our friend's enemy is our enemy. So this turns into 6 take away 4, which is 2. Let's try these problems now. So negative 10 take away negative 4 is the same thing as negative 10 plus 4, because two negatives make a positive. Remember, enemy's enemy is our friend. And we know that negative 10 plus 4 is, you move 4 units to the right. 1, 2, 3, 4. You get negative 6. Now negative 8 take away negative 14 is the same thing as negative 8 plus 14. Now you can reorder this. This is the same thing as 14 take away 8. And 14 take away 8 is 6. Negative 14 take away negative 5 is the same thing as negative 14 plus 5. And when you reorder it, you get 5 take away 14, which is the same thing as 9. And it's negative 14, which is a larger value, so it's a negative 9. Now negative 15 take away negative 17 is the same thing as negative 15 plus 17. And you can reorder it to get 17 take away 15, which is 2. So always keep that in mind, that you can always switch the order. For example, if you have negative 3 plus 6, this turns into 6 take away 3, which is just 3. And if you have negative 7 plus 3, this becomes 3 take away 7, which is negative 4. You see that the bigger numbers symbol is the same thing as the answer symbol. Here, the bigger value is 6, so the answer is positive. Here, the bigger value was negative 7, so the answer was negative. So that was some basic one-digit addition and subtraction. But what if you want to do that to larger values? Let's say, for example, if you want to add 54 and 46. It is impractical to do that on a number line. But what you can do is you can write them like this and perform one-digit addition. 6 plus 4 is 10. So we write the 0 here and we carry the 1 on the next column. And then we add these three values. 4 plus 5 plus 1 is 10. So we write 10 here. So 54 plus 46 is 100. Now what about 125 take away 57? Again, you write it like this. And now 5 take away 7 is a negative value, but you do not want that. So what you do is you carry 1 from here to make this 15, and 15 take away 7 is 8. Now again, 1 take away 5 is a negative value. So what you do is you carry this 1 to make it 0 and make this 11, and 11 take away 5 is 6. So 125 take away 57 is 68. Now what about 69 take away 49? Well, you write it like that again. 9 take away 9 is 0, and 6 take away 4 is 20. So 69 take away 49 is 20. Now one more addition. What if you have 65 plus 79? 9 plus 5 is 14. You carry the 1 here. And 7 plus 6 plus 1 is 14 also. So 65 plus 79 is 144. Let's look at two more examples. So what if you have 45 and you want to take away 68 from it? So again, you write it like 45 take away 68. But notice something different, that the first value is this time smaller than the second value. So what you do is you swap them around to make it 68 over 45, and then you can do it 8 take away 5 is 3 and 6 take away 4 is 2. But since you swap them, this positive becomes negative 23. Now let's do one more. If you have 65 and you want to take away 82 from it, you again write it like that. You swap them, and then 2 take away 5 is a negative value, so you borrow 1 from here. 12 take away 5 is 7, 7 take away 6 is 1. But since you swapped it, the 17 becomes negative 17. So that was addition and subtraction. Now let us look at multiplication. This right here is the multiplication table. The numbers in red are the ones we want to multiply with, and the green ones are the answers, or in this case, the products. So if you want to do 2 times 3, you move from the second column to the third row to reach at 6. So 2 times 3 is 6. This also means that if you add 2 to itself 3 times, you should get 6. And it also means that if you add 3 to itself 2 times, you should get 6. This is because multiplication is the same thing as repeated addition. If you want to do 5 times 4, you go from the fifth column to the fourth row to reach at 20. So 5 times 4 is 20. This also means that if you add 5 to itself 4 times, you get 20. And it means that if you add 4 to itself 5 times, you should get 20. Now, some people might say that these are a lot of facts to memorize, and they are right. But fortunately, due to the commutative property that we will be going through when we learn arithmetics, we know that we only need to memorize half of these facts. That is because 2 times 3 is the same thing as 3 times 2. Let's look at the table. 2 times 3 is second column and third row, which is 6, and 3 times 2 is third column second row, which is also 6. Now, let's look at one more example. What is 8 times 5? What you can do is you can add 8 5 times to get 40, or you can just look at the table from the 8th column to the 5th row to reach at 40. So that was how you do one-digit multiplication. But what if we want to do something like 15 times 8? The same way we do addition and subtraction with bigger values, we write this like 15 and 8 and the multiplication symbol, and we perform one-digit multiplication. So what is 8 times 5? 8 times 5 is 40. So we write the 0 here and we carry the 4 on top, and we do 8 times 1. What is 8 times 1? 8 times 1 is 8, and we add 4 to that 8. So that is 12. So 15 times 8 is 120. How about something like 25 times 13? We similarly write it like this, and we perform single digit multiplication. 3 times 5 is 15. So you write the 5 here and carry the 1 here. 3 times 2 is 6, and 6 plus 1 is 7. So we write 7 here. And now we perform multiplication for this 1, which is in the tens place. So we write a 0 here to start from the tens place, and then we perform 1 times 5. 1 times 5 is 5, and then we do 1 times 2. 1 times 2 is just 2. And then we add these two values. 5 plus 0 is 5. 5 plus 7 is 12. So we write the 2 here and carry the 1 here. And 2 plus 1 is 3. So 25 times 13 is 325. Let's go bigger. How about something like 67 times 39? Similarly, we write it like this, 67 and 39. We perform for the 9 first. So 9 times 7 is 63. So we write the 6 here and carry the 6. 9 times 6 is, let's look at the table, it's 54. So 54 plus 6 is 60. So we write 60 here. And then we perform the 3. But before we do that, we need to add a 0 here. Now 3 times 7 is 21. So we write the 1 here and carry the 2 on the 6. And now 3 times 6 is 18. And 18 plus 2 is 20. So you write 20 here. And now we add these two values. 3 plus 0 is 3. 0 plus 1 is 1. 6 plus 0 is 6. And just 2 is just 2. So 67 times 39 is equal to 2613. So that was multiplication with very large values. But what about with very smaller values? For example, values with decimal point. So if you want to do 0.25 times 15, how would you do this? Similar to everything else we do, we write this as 0 to 5 and 15. And see how I didn't put the decimal point? You can if you wish to, but it confuses me, so I just put it at the end. And now we perform multiplication like we usually do. 5 times 5 is 25, so we add the 5 here and 2 here. And 5 times 2 is 10, plus 2 is 12. 2 here, 1 carried away. 5 times 0 is 0 plus 1. And now we leave a space and do 1 times 5 is 5. 1 times 2 is 2. 1 times 0 is 0. And now we add these values. So this is 5, 7, and 3. But the answer to this is not 375. You see how we have two decimal places after the decimal point? Similarly, in the answer, we leave two decimal places and put a decimal point. So the answer to this is 3.75. Think of it as money. If you want to multiply 25 cents 15 times, what do we get? But we know that 4 times 25 cents make $1. But we need 15, not 4. So we do another 4 times 25 cents. And another 4 times 25 cents. And now we need 3 more. And in this case, it makes 75 cents. Now if you add these values, we should get 15. And when we add these values, we should get $3.75. So multiplication with larger values and smaller values is exactly the same. But with multiplication with decimal points, decimal values, we need to keep that in mind, that how many places are there after the decimal point. And then in the answer, we leave those many numbers and put a decimal point there. So if you want to do 10 times 10, our instinct tells us that it's 100. But how we should do it is we should do 1 times 1, which is 1, and then we add the remaining zeros to it. For example, if you want to do 100 times 10, that is 1 times 1 is 1, add the 3 zeros, which is 1000. If you want to do 100 times 1000, you times 1 times 1, which is 1, and you add the remaining 5 zeros. Let's do this to harder problems. So if you want to multiply 50 times 60, we first do 6 times 5, which is 30, and then we add the zeros, which is 3000. If you want to do something like 500 times 700, we first do 5 times 7, which is 35, and then we add the remaining 4 zeros to it, which is 350,000. Now what if we want to do this to 9700 times 5400? So first we multiply the numbers together. So we do 97 and 54. 4 times 7 is 28, so 8 here, 2 here. 4 times 9 is 36, plus 2 is 38, so write 38 here. And then we leave a 0. And 5 times 7 is 35, so 5 here and 3 here. 5 times 9 is 45, 45 plus 3 is 48, so we're at 48 here, and now we add these values. This is 8, this becomes 8 plus 5 is 13, so you carry the 1. 8 plus 3 plus 1 is 12, 2 here, 1 here, which is 5238. So you write 5238 here, and then we add the 4 zeros to it. So the answer is 52,380,000. So that was multiplication. Now let's look at division. So if you want to divide 35 by 5, what do you get? We can also write this as 35 over 5 as a fraction. They both mean division. So what this really means is 5 multiplied by what number will give us 35. So we go to the fifth column and we select 35, and which row is it? The 7th row. So 5 times 7 is equal to 35. So 35 divided by 5 is 7. Let's look at one more example. What is 42 divided by 6? So this what this really means is what number is multiplied by 6 to get 42. So we go to the 6th column and we find 42, and that is the 7th row. So 6 times 7 is 42, which means 42 divided by 6 is 7. Let's look at one more example. So 64, let's say, divided by 8 is equal to what? So what this really means is 8 multiplied by what number would give us 64. So we look at the 8th column, we find 64 in it, and that is the 8th row. So 8 times 8 is 64. So 64 divided by 8 is 8. Now what if you have a problem like 45 divided by 6? We again do 6 times what number is 45. We go to the 6th column and find 45. But there is no 45. So what do? What we do here is we do long division, which is like this. So we write 45 in here and 6 there. And now we find the one multiple of 6 that is the closest to 45. So which multiple is the closest to 45? 42 is only 3 places away from 45. And 42 is 6 times 7. So we write 7 here and we write 42 here. And then we take away these two values. 45 over 42 is 3. But what we do now is we put a decimal here and we can add a 0 because 45.0 is the same thing as 45. 7.000 is the same thing as 7. So it doesn't matter how many zeros you add, the value doesn't change. But how it helps is now we have a 0. We also need to put a decimal point here. Now we have a 0. We can bring down the 0 to make this 330. And we know that 6 times 5 is 30. So we put 5 here and 30. And the remainder is 0. So 6 times 7.5 is equal to 45. Let's look at one more example. For example, if you want to divide 32 from 5, how would we do it? We write it like this, and the closest multiple of 5 to 32 is 30. And 5 times 6 is 30, so we'll put 6 here, and 30, and we get 2. But remember, we can add a decimal point here, and bring down a 0 to make this to 20. And now we know that 5 times 4 is 20, so we put a 4 here and 20, and we get 0. So 5 times 6.4 is equal to 32. Now, how do you encounter a problem like 80 divided by 6? What we do is we do long division, and the closest multiple of 6 to 8 is just 6. So 6 times 1 is 6, and we bring down the 0, and the closest multiple of 6 to 20 is 18, and 6 times 3 is 18. So now we put a decimal here, and we can add a 0, and we bring down the 0 to make it the 220. Now again, 6 times 3 is 20, and we again 6 times 3 is 18. Now we again have 2, and this is going to keep on going. We are going to keep on adding zeros, and we're going to keep on adding 3's. So the answer to this is 13.3. Repeated. This dash here means that that number is repeated. Let's do another example before we conclude division. Let's say you want to divide 5 by 27. You write it like a fraction. What you do is you do long division, but this time the bigger value is outside. So what do we do now? There's no multiple of 27 that is bigger than 5. So what we do is we put a decimal here and a decimal here to make this 5 into 50. So now the closest multiple of 27 to 50 is just 27. 27 times 1 is 27. And now 50 take away 27 is 23. Now again you put a 0 here to make this 230. And then the closest multiple of 27 to 230 is 216, which is 27 times 8. 230 take away 216 is equal to 14. And now we again put a 0 to make this 14 into 140. And 27's multiple closest to 140 is 135, which is 27 times 5. This again brings us back to 5. So we put a 0 here to make this 50. And 27 times 1 is 27. You take away, you get 23. And you see that it is repeating. 230, and you take away 216, which is 8 times 27. and you get 14, then you bring a 0, 140, and then you do 135, bring a 5 here, to get back to again 5. So this is going to repeat itself. So we can conclude that 5 divided by 27 is equal to 0.185. Repeating this dash here, we know that it means repeating. That means that the answer is 0.185 and repeat itself. So let me show you a trick now that will make your life easier if you have a denominator of 9, 99, 999 and so on. So if you have a fraction as 1 over 9, how would you solve this? 1 over 9 is equal to 0.1 repeated. 2 over 9 is 0.2 repeated. 3 over 9 is equal to 0.3 repeated. And for 2 digits, for example, if you have 45 over 99, this is 0.45 repeated. If you have 65 over 99, this is 0.65 repeated. If you have 125 over 999, this is 0.125 repeated. And it goes on forever. If you have 12554 over 905 nines, this becomes 0.12554 repeated. So that's a nice trick to remember if you ever encounter a problem with 9 as a denominator. Now what if we have a denominator of 10 or 100 or 1000? This is even easier. Let's say if you have 5 over 10 and the decimal point right here is here, yeah? So we move one space to the left to make this 0.5. If you have 50 over 100, the decimal point right now is here, and you have two zeros, so you move this two spaces to the left. 1, 2. So this becomes 0.5 as well. If you have 67 over 100, two zeros, and the decimal point is here, this goes back 1, 2 to become 0.67. If you have 976 over 100, so two decimal places, two zeros, and the decimal point is here, so this moves two decimal places to the left, 1, 2, to become 9.76. Let us briefly discuss how to add, subtract, multiply, and divide fractions. So let's go through addition first. So first we will look at fractions with the same denominator. So if you have 5 over 3 and you want to add 2 over 3 to it, what you need to do is you need to add the numerators together. So this becomes 7 over 3. Note that this does not become 7 over 6, as you do not need to add the denominators together. You only do 5 plus 2. You only add the numerators. Let's look at another example. If you have 6 over 10 and you add 4 over 10 to it, you add the numerators together to make it 10 over 10. And 10 over 10 is 1. If you want to add 4 over 6 plus 3 over 6, this becomes 7 over 6. You add the numerators together. This is because you do not add the denominators, because if you have a pizza, 4 pieces, and you have one slice, and you want to add one slice to it, this is 1 over 4 plus 1 over 4. 4 means that the total number of pieces are 4. This becomes 2 over 4. This does not become 2 over 8 because there are not 8 pieces, there are only 4 pieces. Subtraction is the exact same thing as what we did in addition. If it's the same denominator, you just subtract the numerators, and if it's a different denominator, first you make it same and then you subtract the numerators. Exactly how we did in addition. So let us look at multiplication now. If you want to multiply 5 over 4 times 3 over 6, what we simply do is you times the numerator and denominator. So this becomes 15 over 20. And 15 and 20 are multiples of 5. So 5 goes into 15, 15 goes into 5 3 times. So this becomes 3, and 20 goes into 5 4 times. So this becomes 4. If you want to multiply 6 over 10 times 4 over 10, unlike unlike addition and subtraction, you do not make this 6 times 4, which is 24. You do not make it 24 over 10. You need to multiply the denominator as well. So this is 24 over 100, which is same as 0.24. So let's look at another example. If you want to multiply 5 over 4 to 3 over 2, what do you get? 5 times 3 is 15, and 4 times 2 is 6. No, not 6. 4 times 2 is 8, so 15 over 8. Dividing fractions involve multiplying them. Let me show you what I mean. If you want to divide 5 over 10 divided by 2 over 5, you make this denominator into multiply, and then the second fraction you make it reciprocal, which is 5 over 2. You flip it around, and now you can do multiplication, which is 25 over 20, which becomes 5 over 4. So for dividing fractions, you need to, let's say, a over b divided by c over d. This would turn into a over b multiplied by the reciprocal of c over d, which is d over c. So if you want to divide 5 times 4 divided by 3 times 2, this turns into 5 times 4 multiplied by 2 times 3. You swap it around, and now you can make it 5 times 2 is 10, and 4 times 3 is 12, which turns into 2 times, so this becomes 5, and this becomes 4. Again, 5 over 4. Not 5 over 4, 5 over 6. And that's how you divide. For dividing fractions, you need to swap the second fraction and change the divide sign into a times sign. And we know how to do multiplication. We just multiply the numerators and denominators. There are 3 types of fractions: proper fractions, improper fractions, and mixed fractions. Proper fraction means that the numerator is smaller than the denominator. For example, 1 over 2, 3 over 5, 6 over 10, 7 over 20. These are proper fractions because the numerator is smaller than the denominator. Improper fraction is when the denominator is smaller than the numerator. For example, if you have 10 over 2, 15 over 6, 20 over 4, 5 over 4. These all are improper fractions because the numerator is greater than the denominator. Now what a mixed fraction is you can convert these improper fractions into proper fractions by making them mixed fractions. What a mixed fraction looks like is 2, 5, and 4. This is an example of a mixed fraction. This 2 is a whole number, 5 is a numerator, and 4 is a denominator. How you convert this mixed fraction into improper fraction is you multiply the numerator and the denominator together, and then you add the result to the numerator. So you do 2 times 4, which is 8, and then you add 8 plus 5, which is 13 over 4. Let me show you what I mean in detail. To convert a mixed fraction into an improper fraction, what you need to do, let's say if you have a mixed fraction called A, B, and C. What you need to do is you need to multiply A and C together and add the result, you need to add it to B. So you get A multiplied by C, and the result you add it to B, and whatever you get, you divide it by C. Let me show you an example. If you have 4 over 6, what you need to do first is you need to multiply 5 and 6 together to make 30, and then you need to add that to 4 to make it 34 over 6. See how it's improper now because the numerator is greater? Let's look at another example. 6, 2 over 4. So first you do 6 times 4, which is 24, and then you add the 2, which is 26 over 4. Again, improper. Now, how to do improper to mixed fractions? To convert an improper fraction into a mixed fraction, what you need to do is you need to divide. For example, if you want to convert 20 over 6 to an improper mixed fraction, you need to divide it, and the closest multiple of 20 to 6 is 18. So this is 3, 18, 2. Let's keep it like that. Now what we do now is I use an acronym called D and W. D for denominator, N for the numerator, and W for the whole number. And we know that 6 is a denominator, so I move clockwise from 6. So this is D and W. So 3 is the whole number, so this turns into 3. 2 is the numerator, 2 over 6. Let's confirm. 6 times 3 is 18. 18 plus 2 is 20 over 6. 20 over 6 is the same as 20 over 6. Let's look at another example. If you want to divide 15, if you want to convert this 15 over 4 to a mixed fraction, you need to divide it first. And the closest multiple for 15 of 4 is 12, which is 3 times. So we remain with 3. Again, D and W. So D is the denominator, so you add D here and move clockwise. D and W. So 3 is the whole number, 3 is the numerator, and 4 is the denominator. 3 times 4 is 12. 12 plus 3 is 15 over 4. Let us now look at arithmetics. So, what does it mean by arithmetics? Well, sometimes when people use the word arithmetics, what they really mean is maths or working with numbers. Often, arithmetics is used to refer to the 4 basic math operations: addition, subtraction, multiplication, and division. But what does it mean by math operation? Well, mathematics involve numbers and operations, and these operations tells us what to do with the numbers. For example, the addition operation tells us to take two numbers and combine their values. For example, if you take 5 and 3 and you combine their values to form 8, you perform addition. Subtraction subtraction operation tells us to take one number away from another. So when you take one number away from another, you perform subtraction. Multiplication operation tells us to take one number and repeat it a certain number of times. For example, 4 and you repeat it 5 times to get 20. If you add 4 to itself 5 times, you also get 20. This is because multiplication is the same thing as a repeated addition. The division operation tells us to take one number and divide it into a certain number of equal groups. For example, if you take 15 and divide it into 3 equal groups of 5, you are dividing 15 into 3 equal groups. If you think about it, you'll know that division is the same thing as repeated subtraction. Let's say you have a set of problems. How do you figure out which operation you're going to use? You see that the signs are different in each question. This is because each operation has a different symbol. The addition operation has a plus symbol. So whenever you see the plus symbol, you know you have to add those two values. The subtraction symbol is a takeaway symbol. So whenever you see the takeaway symbol, you know that you have to take those two values away. Multiplication symbol is this X symbol, and often you also see a dot or a bracket. Don't get confused, these both mean multiplication. And division symbol is this symbol, and often you see this symbol as well. This means long division. This is used in long divisions mainly, and you also sometimes see a fraction. So here I see plus symbol, so I know I need to add those two values. I see takeaway symbol, I know I need to subtract. I see the time symbol, X symbol, you multiply, and I see the division symbol, I know I need to divide. Another important symbol that is used in arithmetics is the equal sign. This equal sign separates the set of operations or operation from its answers. On one side of the equal sign is the operation that needs to be done, and on the other side is the what we get after we do the operation. Speaking of answers, each arithmetic operation has a different answer name. For example, if you perform addition, the answer is called the sum. If you perform subtraction, the answer is called the difference. If you perform multiplication, the answer is called the product. And when you perform division, its answer is called the quotient. For addition and multiplication, the order of the order of number doesn't matter. For example, 3 plus 1 is the same as 1 plus 3 because they both are equal to 4. And for multiplication, 3 times 2 is the same as 2 times 3, as they both multiply to become 6. When you switch the order of numbers and still manage to get the same answer, the technical term for that is that the operations commute to each other, or that they share the commutative property, which means A plus B is the same thing as B plus A, or A times B is the same thing as B times A. So addition and multiplication share the commutative property, but unfortunately subtraction and division don't. 1 take away 10 is not the same thing as 10 take away 1, because this is negative 9 and this is positive 9. Same thing with division. For example, 15 divided by 3 is not the same thing as 3 divided by 15. This gives us 5 and this gives us 1 over 5. So subtraction and division do not share the commutative property, but addition and multiplication do. Another important thing about these arithmetic operations is that they form pairs that are called inverse operations. For example, addition and subtractions are inverse operations. And what is an inverse operation? Inverse operation is like an undo feature on a computer. You do something, you press undo, and it reverses it back to its original state. Similarly, for addition and subtraction, if you have 10 plus 20, if you add 20 to the number 10 to make it 30, you can undo that by taking away the 20 from the 30 to make it back to originally 10. Similarly, multiplication and division are the inverse operations of each other. If you multiply 5 times 10 to make 50, you can undo that by dividing 50 into 10 equal groups to make it back to originally 5. Multiplication groups things and division ungroups them. We have learned a lot about arithmetic so far, but when we actually do arithmetics, it is very helpful to memorize all the basic arithmetic facts, such as memorizing answers to all arithmetic problems for multiplication, subtraction, addition, and division that can be made from the numbers 1 to 10, like 4 times 3 is 12, 1 plus 2 is 3. All of these facts for all of the operations for numbers 1 to 10. Now, you may think that that is a lot of facts to memorize, and you are not wrong. But fortunately, we can cut down these facts by the two things we learned today. Inverse operations. We only need to memorize facts for addition and multiplication, because then you can figure it out how to subtract and divide. For example, 3 plus 7 is 10. If you know this fact that 3 plus 7 is equal to 10, you also know two different subtraction facts, that 10 take away 3 is 7 and that 10 take away 7 is equal to 3. This group is sometimes referred to as the fact family. Similarly, for division, if you know 5 multiplied by 4 is equal to 20, you also know two division facts, that 20 divided by 4 is equal to 5, and you also know that 20 divided by 5 is equal to 4. So you only need to memorize all the operation facts for addition and multiplication. If you know them, then you can do inverse operations and figure out subtraction and division. But memorizing all the facts for multiplication and addition is still a lot. But fortunately, we only need to memorize half of it because of the commutative property, which means that we can switch the order of the problem and still get the same answer. For example, if you know that 10 plus 4 is 14, you also know that 4 plus 10 is 14. And same thing for multiplication. If you know that 5 times 3 is 15, you also know that 3 times 5 is 15. So all you need to do is you need to memorize facts for these, but only half of it, which makes things a lot easier. That concludes our lesson for today. Thank you all for watching. I will see you guys in our future video. But till then, remember, math is fun.